name is Kat. I'm a geology graduate with I'm a graduate with a bachelor's in geology, and I'm hoping to make some use of it because I'm not exactly a professional geologist at the moment, but I still learned a lot of stuff that I think would be neat to teach you guys. So let's go ahead and start our first video. The first videos will just be rock ID to get you guys warmed up into what a normal geologist might do in their day-to-day. There's so much more that you can do with it that I'm not going to get into right now. I mean, there's like exploration geology, there's just so much that you can do. I'm kind of blanking on them at the moment, as you can tell. Please excuse me, this is my first video, so I am nervous, and it may be obvious. But yeah, so let's start with rock ID, which was actually one of my least favorite parts of my classes, believe it or not. But it's not because rock ID isn't interesting. I don't want you to get discouraged to continue watching. It's just that it is not what I was interested in. I wanted to do stuff with seismology. So I kind of took my classes for granted. I didn't pay that close attention, so that's a lesson to you guys. Pay attention, because you never know when you're going to end up using something. That's not just something the teachers say that's a cliche and it's not true. You'll be surprised. So, let's start with this little guy. It's kind of hard. I'm going to try to see if I can get a good view. If you see me looking over here, it's because I'm checking my camera to see what you guys can see. This is one of the rocks. I'm going to be looking at 10 today. We'll see how I split it up for the videos. This guy, you can actually find him pretty much most places in Pennsylvania, which is where I am. They're very common. I could get into the history or the geology of the region, but I think I'll save that for a future video. For now, I'm just going to focus on the rocks themselves, and then we'll get into why certain rocks look certain ways in certain places, and why you can't find certain rocks in other places. We'll get into that later. For now, I'm just going to, like I said, focus on telling you what these dudes are. This little guy is a quartz sandstone. They're pretty common, I'll say that much. And when it comes to rock ID, you're going to be looking at three major categories. Either they're igneous rocks, which means that they are the closest to their volcanic origin. They're sedimentary rocks, which means that they've had time to actually cement and become like the kinds of rocks that you see everywhere. You don't see igneous rocks in a whole lot of places when you're walking around, but the rock that you're going to see most commonly is sedimentary. That means that there's been some activity since the rock was created, I guess, since it came about. And that's most rocks in the world. You don't see a whole lot of new rocks at the surface. And then there's metamorphic rocks, which are the ones that have undergone the most transformation. And it's usually from some kind of pressure, some kind of heat. Again, I'll get into the specifics of that in another video. The metamorphic rocks look really cool, and I actually do have a few examples here with me. You'll see what I mean. So yeah, this guy is a sedimentary rock because it's a sandstone. And again, in sedimentary, you have like so many classifications that you can go for. So when it comes to sedimentary rocks, there's like a whole bunch of different classifications that you can get. There's actually several big categories. But the two biggest ones for sedimentary rocks are inorganic clastic sedimentary rocks, which just means that there's no biology that was getting mixed in, no living organisms had any part to play in this whole process of the rock becoming the way it is now. Or it is chemically or organically formed sedimentary rocks, which, means that there's been chemical reactions to form the rocks, or that there's been biological activity to form the rocks. Another way that you can think of the first category, the inorganic, is just that it's just physical processes forming the rock. The second one has to do with chemistry, either because there's biology involved or because there's just chemical reactions happening between minerals. So the first category, inorganic, simplest category you can think of, nothing special going on there, I guess. That's my way of clarifying what I'm talking about. It is really cool stuff. It's not nothing interesting going on. That's just how I'm phrasing it for now. And then there's the chemically or organically formed sedimentary rocks. This guy falls in the first category. It's inorganic. It's a sandstone. And it's a very finely grained sandstone, which is pretty common. Again, you can't see the individual rock pieces in here. You just see what looks like a large gray mass with white things going through. The white things I'll explain in a couple of seconds, but the gray mass are actually a lot of little particles of rock, and they're sandstone. They're all quartz, actually. And they're largely quartz in chemistry, in like the actual mineralogy. And again, as I go on, I will keep explaining these things and getting more into detail about what I mean. And if you guys have any questions, of course, you can always drop them in the comments. I have no problem explaining certain things that I just didn't capture that well. I'm not a teacher, but I do like to teach, so let me know if you need any further explanations. The white things that you guys see are quartz veins. So basically this entire rock is made of quartz. The quartz veins just happen to come later through gaps that were already forming in the forming sandstone. And it just filled up with probably more pure quartz than, well, it's equally as pure, but like newer quartz filled the little gaps, and that's why they still look white. Alright. This is a bigger example of the exact same kind of rock. It is a different sample of rock, believe it or not. I did not get these two rocks at the same time. This one, the small one, I got recently on a walk. This one, I can't remember. I should probably start noting when I pick these up. That's another thing. I made the mistake of when I was picking up a lot of these rocks, not noting where I was getting them from. But the cool thing about geology is that you can kind of find out where they came from and where you might have gotten them just by looking at them. These were both picked up in Pennsylvania, I can tell, because this one I definitely picked up in Pennsylvania. This one looks almost exactly the same. Really, a lot of the region of the Northeast is similar geologically. So it could be anywhere from the Northeast if it looks like this. Again, I'll get more into detail about that later. And if there's any geologists that want to pipe in and explain certain things in the comments as well, you're welcome to. I'm just trying to teach people some things that they might not necessarily want to pay to go to university to learn. But yeah, so again, quartz veins, big white things. These have cooler quartz veins. They're bigger than the small one. So you can actually see more of the detail of it. It looks so cool. I'm going to try to hold it as close as possible without hitting the camera. Ooh. Yeah, there we go. And now, those two are quartz sandstones, like I said, with quartz veins in them. This is likely, according to the notes that I took on it, because the thing about rocks is that you have to spend a lot of time really looking at them to try to figure out what they are and what's in them, what's part of the composition. Let me get my fingernails out of the way there. But you could still be wrong because you don't have the... Unless you crack these guys open, all you're really looking at when you're looking at the outside of the rock is the weathered surface, which means that there's been water, wind, activity. There could be biological components like, you know, those little, they call them lichens. I've heard it pronounced that way. It's Lichens. It's like little, what are they called? Like little bacteria growths, like little communities of algae and stuff like that. That could be, sometimes you see those on rocks. That's not part of the rock. That's something that is growing on the rock. So do not consider that part of when you're trying to ID something. It might be hard to tell sometimes. That sounds obvious, but sometimes certain things that you see look like they're part of the rock until you wash them off or until you pick the rock up. So yeah, this could potentially be diorite according to my notes because they've got two different types of grains in color. One is lighter, the other one is darker, which means it could be a diorite. But at the same time, if I crack this open, I might see a very different story, and I have had this rock for so long that I have no idea where I got it from. I would literally have to crack it open to see what's in the inside. That's the thing. Usually if you want to get past the weathered surface of a rock, you just crack it open with a rock hammer. Do not try to do it with a normal hammer. It's going to be a little hard. You probably could. But please don't do it around anything breakable. And please don't hit your fingers. If it's a really small rock, it might not be worth trying to crack it open because you're probably going to end up hurting yourself. Just for anyone that's trying that at home. But yeah, so if you're looking at the outside, it's the weathered surface, so you might not get accurate rock ID from that. If you want to get more accurate, you can just crack it open, saw it open. There's actually rock saws. Again, please don't just walk into some random place and ask to use it. They might surprise you and let you, but I very much doubt it. So yeah, that probably diorite. We'll have to crack open to be sure. I very much doubt that it's diorite though. It looks like it, but I just can't remember where I got it from. And diorite, as I mentioned before, there's igneous, sedimentary, and metamorphic rocks. Diorite is an igneous rock. It's closer to its volcanic origin. It basically means that it's a mix of two different compositions. One is felsic, the other one is mafic. That's why, like, if you see, they tend to, the way that I heard it described when I was in classes, it's kind of like a Dalmatian. Like, where you get a mix of dark and light colored grains, and that makes up a diorite. And that's the simplest way I can possibly explain that without getting into too much detail. It's just, yeah, you're just going to see essentially black and white rocks mixed together. And if it's not a weathered surface, that's a good idea. That's a good hint that it might be a diorite. But I would have to crack this open because I don't trust any weathered surface on a rock, especially one I've had for so long. Kind of looks like it has a crack through it that's going to be easy to break it open through, but maybe I'll do that in another video. So this guy is kind of interesting. I think it's a river rock, because you can pick up a lot of really cool rocks from the rivers. They, believe it or not, they're not all the same. they tend to be quite different in composition and in where they came from for that reason. This guy, I don't know if it's going to show up very well on this camera. Kind of try to hold it up. You see those little ring looking patterns, like tree rings? That is a hint of erosion. That's like the water constantly pushing up against the rock, and while it's rounding it, which is why it has such a nice round rather than angular, because a lot of, if it's, the more angular a rock is, kind of a little tangent, the closer it is to its source, because the less work that has been done to it over time. As the rock is out in nature longer, water, wind, other types of sources, usually just water and wind, they'll work together to round the rock out and just kind of smooth over jagged edges. So the rounder a rock is, the longer it's been out there, and the more likely it is that it's been close to a water source, because water is a very, very strong weathering source. Like weathering pressure? I don't know what I'm trying to say here, but you know what I mean. I hope you know what I mean. So yeah, the rings are actually a sign of erosion from the water as sandstone continues to be ground down, because this is probably quartz as well. Let's be real. If a rock is this round and it is still intact, it's probably comprised of quite a bit of quartz, because quartz is the most durable mineral that there is. It is very difficult for quartz to be ground down completely. That's why a lot of cliffs as well have the shape that they have, which I will also get into another time. But yeah, so those little rings are a sign of erosion. As the weaker layers that are exposed to weathering longer start to get knocked away, the rings start to form, because that's just you seeing the rock beneath starting to come out. So yeah, it's really cool. All the rocks that I'm showing you so far would be considered boring by geologic standards, because they're not the cooler looking rocks that you see out there. But honestly, I just think all rocks are cool, and maybe that's just because I'm a nerd and I like learning about rocks. I've actually been picking up rocks since I was a kid from the ground. Kind of weird that I ended up being a geologist in terms of like professional, but hey, this is a pretty nice way to make use of my education, I think. Now, this guy, this is a cool dude. This is an example of a rock that looks boring, but is actually really interesting to me. I don't care what anyone says. Don't ever let anyone convince you that shale is boring, okay? Shale is literally so cool. This guy is actually a red slate though, which is a metamorphic version of shale, I guess is the best way I can describe it. Other rocks can become slate too, but it's more likely to happen with a shale. So a shale is essentially just a mix of really finely grained sedimentary like rocks that kind of form fissile layers, and what that means is that it's kind of like plates stacked on top of each other. So if you look at a shale from the side, you can kind of see the rocks starting like forming little layers. I think I'll just insert a picture of a shale at this point so you guys can see what I mean. That little texture is called fissile, and it just platy fraction, like platy points where the rock can be probably pried apart, if you can imagine. A slate is a metamorphized version of that, which basically means that there's been enough pressure put on the rock that even though you can still kind of see the same layers, you can't pull them apart that easily anymore. It's really cool. Like, that's one of the first stages as well of metamorphosis. Metamorphosis? Is that what it's called for rocks? I can't remember. But yeah, like, that's the first stage of a metamorphic rock. Because it continues to be metamorphosed into, like, phylites, and then in schists and gneisses are the very end of that little scale. But we're not going to get into that right now. I will probably make a video explaining every single classification for sedimentary rocks, the classifications for igneous, the metamorphic classifications. If you guys want that, just let me know. So this is a red slate. This is going to be extremely difficult for me to show you the texture. Hopefully, as I'm holding it, you can see those cool little layers that I'm talking about that you cannot pull apart because they are actually very stuck together now. So the reason that I'm saying it's slate instead of shale, because how can you tell the difference? You're probably wondering. Sometimes it might be difficult to tell. So a shale, like I said, is more easily breakable. You can probably chip at the layers and kind of pull them off from the corners, right? You're not going to be able to pull the whole thing off, okay? Let's not exaggerate. You can probably get your finger under there and just kind of chip off a little bit so the layers, that they stick out from the rest of the rock. You cannot do that with the slate. And it is finer grained than a shale, so the grains are even smaller, so it has a very smooth sheen sort of to it, and that's how you can kind of, the light is not helping, but under natural light you can tell that there's a little sheen to it. It looks extra shiny probably in this bright light. It's not actually that shiny in real life. It just has a slight sheen to it. And it's very smooth, is another sign. It's very, very smooth. Shales are not usually this smooth. Now, on to the next one. And if you hear me thinking every once in a while, please don't mind. I just tend to do that sometimes. So this guy is a chert, which is another really cool rock that I don't think a lot of people appreciate how interesting it actually is. And they tend to consider it pretty boring. Okay, so this is a chert. That's another rock that a lot of people take for granted, and a lot of people will probably not be very interested in this one. The cherts and shales are really the unsung heroes of geology, in my opinion. They are so cool, but not enough people give them credit because they don't look as awesome as rocks that you find in a mine. Well, obviously, if you're looking for crystals, you're not going to go looking for rocks. You're not going to find a whole lot of really cool garnets and, like, you know, diamonds and emeralds and rubies and all that stuff. This is not that kind of geology. Okay, this is normal rock geology. This is the everyday common folk geology. But, you know, just like you probably know if you've had enough experience in the world, there are some really cool people amongst the so-called normal people of the world. And this is an example of someone that you would not expect much from, but it's actually pretty cool. So I'm going to try to show you the colors and describe the texture to you. So, if I did this correctly, you can see that there is actually a contrasting color here. The red is due to iron oxidation. The gray is due to organic matter being mixed in over time as this rock formed. This is a chert, as I said before. This is formed in the ocean. It is not formed on land. This has to form in the ocean. That's just how it works. I'm going to get into more detail about that, obviously. Iron oxide is basically just what happens when you have iron minerals in a rock that react with oxygen either in water or air as it's exposed to either, and then it just starts to turn the iron red. Why that is, I don't understand the chemical reaction myself. You could probably Google it if you're that curious. Like I said, the great thing, like I said before, are inclusions of organic matter that have kind of gone mixing with the rock, because the way that sedimentary rocks form, sometimes they form with, no, always the way that they form is with rocks, different rock parts coming together and solidifying and cementing into a rock. So this could be organic matter, this could be carbonates, this could be any number of things. It could be more iron, who knows, you know? So also, the thing about the texture for these rocks, I don't know if you can tell, but it looks pretty smooth. That's because it is. It feels like plastic. It's plasticky smooth. And that's how you know it's a chert. That is the thing that tells you it's a chert. No other rock has plastic smooth type of thing. I know I just said the slate is very smooth. It's not plastic smooth. You'll tell the difference as you keep comparing them over time. These are two little pieces of the chert that, oh, I dropped that. This is a little piece of the chert that has broken off. Because chert can be broken. It's not that, it's pretty easy. It's not easy to break. I wouldn't say it's that soft and weak of a rock, but you can have pieces of it fall off with enough, like, abrasive force. Now, we're going to get into the last boring rock that we have. And that is a river rock. Again, river rocks are really cool. You see how smooth this is? You probably can find this in like a garden store or some other landscaping shop for me to show you. This, though, is actually natural. This was formed in rivers as continuous water forces just kept rounding out the rock. And this is all quartz. As you can imagine, what did I tell you? If it's really round and it's still compacted closely together, it's probably a quartz sandstone. So, it's really cool. I just keep it on my desk because honestly I just like looking at it. This is the perfect skipping rock, probably. This is a really cool rock. I do not want to skip it anywhere because then I'm never going to see it again. Now we're going to get into the interesting rocks. Because the way I'm going to try to split this up is, for every video it'll be some boring rocks and then some really cool rocks. I think all rocks are cool. I don't discriminate. I love all my kids. So this rock is scoria. This is an example of an igneous rock. Yet again. I think I've already shown you guys one. Yeah, the potential diorite. This is a definitive igneous rock because it's scoria. It's basically just volcanic rock. There's a specific word for it. Vesicular. That's the word that I was looking for. It took me a second, but I thought of it. So vesicular just means that it's full of tiny little holes that gas used to live in before it left the rock and it left the holes in them. And so this is volcanic rock. This is basaltic volcanic rock. So basalt is just a darker volcanic rock, while felsic is, well, actually, mafic is the darker volcanic rock. Basalt comes from that. And felsic is the other type of rock aside from mafic that's lighter colored rocks. And yeah, there's a lot of cool stuff in both categories, but this is definitely a mafic volcanic rock, and it's definitely basalt, I would say. And it looks really cool. It just has tiny little holes. Every time I see a rock with holes in them, I like to think that there's little creatures living in those little holes, even though I know that that's not logically possible, but, you know, imagination. You can still have that at my age, it turns out. Don't ask me how old I am. And this rock is another really cool rock. So, this is a phyllosilicate. I'm going to hold it up so you guys can see it before I talk your ears off. I hope the light is not hurting. The light placement is supposed to help. Oh, those shadows are awful. I'm going to try to turn it to see if you guys can catch a little sheen. Yeah. So, this looks way cooler in person. I'm so sorry. There's nothing that a camera can do about that. This little guy, not unless I hold it and like put it right up there and just move it around, and I don't feel like taking that out of its mouth. So, this little guy is a phyllosilicate. This is a phyllosilicate. It is muscovite mica heavy. That sounds weird and confusing probably to someone who's never heard any of those phrases before. To you, that just sounded like words. So I'll explain. A phyllosilicate refers to the actual shape, I guess that you could say, of the crystal bonds. So I don't want to get too into chemistry because then I'm going to lose some of you. But the way that the atoms are formed when it comes to crystal shapes is that sometimes they form the crystals that you expect, like a hexagon or, you know, like a normal shape that you would see. Or they can form these cool little things where they kind of form into sheets because those are very weak bonds between them. and it only holds them together very weakly, so you can pull them apart pretty easily and they form sheet-like minerals. And that's what is in this guy, except this guy is not just a sheet mineral rock, okay? That would just make it igneous, probably. The thing about this dude is that you can tell that it has had some metamorphism happen to it. This guy is actually a schist. So remember how I told you that there's different grades or different levels of metamorphism? It's called different grades. The different levels are referred to as grades. But anyway, so this is a mid-level, mid-grade metamorphic rock, you could say, because it's a schist. It's like this guy is a third level. I'm trying to figure out how to explain this. There's 4 different grades of metamorphism for the most part. The first grade is just slate. The second one... Okay, so there's different levels of metamorphism. Let's just put it as simply as possible. There's like the lowest tier of metamorphism, which is just referred to as a slate. Then there's the second tier of metamorphism, which is referred to as a schist or a phyllite. And then there's the third grade of metamorphism, which is the highest possible grade, which is a gneiss. And it's called that, but it's not spelled the way you would think. It's Gneiss. That basically refers to a rock where like color banding tends to be very obvious in those types of rocks. Like it's the cool rocks that you see that just have bands of different colors, like all nicely oriented, and it looks like somebody with OCD put the rock together. That's a gneiss. That's the nicest. That's the best way I can explain that. This guy falls somewhere in the middle because it's a phyllite. And it just has a whole bunch of sheet crystals very visible along the breakage point of the rock. The other side of the rock is extremely slippery, I guess, smooth as well. You can also see that it is just as shiny and plated as this side. But it's actually a little less shiny because there's different types of stuff happening on this outside because this is the weathered surface of the rock. This is the inside. So yeah, wherever you see weathering, unfortunately, the cool things that the rock did to form kind of start to get taken away from your visible eye, so you'll have to crack it open because there's chemical reactions happening on the outside of the rock as water or air is reacting to it. So you're not going to see really cool stuff on the outside usually. Unless the rock is just that cool that it still managed to retain that stuff. Or you just got lucky enough to see it before much happened to it, or some gaps in history didn't really touch the rock, etc. But yeah, so this little rock, this rock tends to form in regional metamorphism because so metamorphism can happen in several different ways. 2 of the big ones that you're going to see are contact metamorphism, which just means that really hot rocks came into contact with really cold rocks of another kind, and the 2 rocks metamorphosed, and then you see really cool stuff kind of that. And then there's directional metamorphism or regional metamorphism, which just means that there's forces that are pushing in specific directions that are causing the rocks to become more foliated, which just means layered, banded, etc. And it's also causing really cool stuff to happen with the rocks for that reason. So in terms of regional metamorphism, because that's what this rock indicates, contact metamorphism has completely different types of rocks typically. This is really just pointing to regional metamorphism because it's the second grade of metamorphism. The grades you see in regional. I really should have explained that earlier. You're not going to see that much grading of metamorphism in contact metamorphism. And again, I'll explain that later. But yeah, so this guy is one of the cool rocks, quotation marks. And then there's this guy. This guy is going to be difficult to explain. I already know it. So this guy, I actually picked up in a mine. This is one of the rocks that you are not going to find just sitting around anywhere that you walk. Because I specifically picked it up in a mine. I hope I can show you some of the really cool details without the light kind of messing it up. And you see those little flashes of red? That's garnet. The black stuff in this rock could either be hornblende or andrite garnet, which just means it's like a black version of garnet. That's really all that means. It's also referred to as melanic garnet. Supposedly, I've never heard it referred to that way before, but melanitic, I should say. Sorry, that's the wrong pronunciation. So these rocks tend to be found at skarns, which are just places of contact metamorphism. Remember how I was talking about how there's two major causes of metamorphism: contact and regional. Regional happens usually when mountains are forming. There's collision that tends to happen more along convergent boundaries. Now, contact metamorphism can happen at any kind of tectonic plate boundary. And it's just meaning that rocks that are hot are coming into contact with rocks that are cold, and they're deforming them, pretty much, and doing cool stuff with them. This is a contact rock. Like, this is a contact metamorphism rock. This was found, these are typically found at skarns, which are just the name. A skarn is basically just a name for a place where contact metamorphism happened. There's no simpler way to describe it than that. This I found at a mine where they're digging. Mines tend to find places where, I guess I don't want to go into exploration geology at the moment, but typically the way that exploration geology works is that whatever type of rock the company is looking for specifically, they will hire a geologist to find them. And if a geologist knows what they're doing, they know where to find rocks like garnet. It's probably going to be in places of contact metamorphism. So they look for skarns and things like that. And that's what this is. Sometimes they invite students of geology to go out, to go to field trips, and to go on field trips there to look at these types of rocks. That then, they have more hands-on experience with IDing less commonly found types of rocks on the surface. And this is an example of it. And sometimes they're also nice enough to let you take samples. Some places you're not allowed to. Technically. Don't get caught. Okay? This is not one of the places where I was not allowed, obviously. I would never show that on camera. I would never steal anything. But yeah, so this is a garnet. And the black stuff is probably hornblende. It's kind of sad that you guys probably can't see it. I don't know if the camera shows just how shiny this rock is. No, it seems to show it. Yeah, everything is gleaming. All that gleaming stuff is just quotation marks, quote unquote, hornblende. Let's just put it that way. It could be another type of rock because there's so many rocks that this could be, but I'm going to assume it's hornblende because that's usually the safest option. If there's anything that I've learned while I was in school, and this guy is the coolest. Okay, let me not give it too much credit, okay? Let's not make any rocks feel like they're the favorite of the family. But this is definitely, if I was playing favorites, we all know who would win the title. This is a wollastonite. This is from a mine as well. You're probably thinking, how many places just let you go in and collect rocks? Some places are nice, like I said. Some other places where the rock is extremely high value, they will not let you take any samples. This apparently is not one of those mines where they're going to get finicky about that. So basically, this wollastonite is like a really big sample because I have a smaller sample up here somewhere that I'll show you guys in another video. But this is a large sample that I have. This is really cool. This fits in my palm like this. A lot bigger than the other rocks you may have noticed. The black minerals could be andradite garnet, like I said. Remember the melanite? Yeah. It's just the black variety of garnet, essentially, is what you're saying here. So yeah, there's a lot of... I may have gotten this from the same mine. I just visited so many on that trip that I can't remember where I got which ones, but I think this probably came from the same one. That would make the most sense logically. So the thing about wollastonite, right, like that's the name of this rock, just ignoring the little... And now, as I was saying, because the GoPro decided to turn off. Now, as I was saying, I lost camera battery there for a second, but I'm going to try to finish this in the last possible potential minutes. This little guy is a wollastonite. I am just holding the camera at this point so I can actually make sure to get as much detail as possible. Let me see if it focuses. Nope. In any case, it is really cool stuff. Thank you guys for coming with me for the first video. I know it's a little rough, but I'll get better at this as I go along. And... okay, everyone, I was trying to avoid having to do an outro on my phone, but I did run out of battery for the camera, so I am just going to finish us off here. This will be an outro. I think I'm gonna do this for all the Rock ID videos. I just finished up by showing you guys the whole pile that I just went over. And there's 10 rocks total in here if I'm not miscounting. I just had to count it again mentally. So yeah, these are 10 rocks. The little chert. Wow, this camera's actually better for showing you the rocks. That's interesting. Yeah, maybe I should do Rock ID with these. Huh. With this camera. You never really think that your phone camera is going to be useful for anything, but then it surprises you. In any case, these are the rocks that I went over, and I will be going over way more in the future. As you can see, I have a lot of rocks. A lot of rocks. And this is my fossil collection, but I'll go over that in another video. Don't even look at that. I'm just going to look away before you get too excited. But yeah, so I have a whole bunch of rocks. I will be going over them. That will be the first series that I do, just IDing all the rocks that I have currently. Because my plan is that once I'm done cataloging the rocks that are currently in my collection, I'm going to go out there and collect more. And you guys are going to come with me for those trips. We're going to be like little exploration geologists ourselves to see what we can find out there. I hope you guys enjoyed this first video. And if you have any requests, any questions, any necessity for me to make videos going deeper on certain topics or certain Rock ID classifications, just let me know in the comments. Also, let me know how I'm doing. This is my first one, so obviously not going to be the best quality. I cannot wait to see what this becomes. Alright everyone, stay curious.